Yeah. So yesterday we saw teachable machine, the model, in teachable machine, and we were able to kind of kind of export it and create a React application, and we saw how we are able to upload the images, and it was working perfectly fine, right? Pretty much decently trained, I must say, right? It was performing really well. We uploaded papaya, I said it's not mango. We uploaded mango, it said mango, and that was working very well. Okay. So today what we are doing is we are trying to take a MobileNet model directly from Keras, right? TensorFlow Keras, and this is the library, the framework for all these these models, and we directly try to use it. Okay. So if you see under the hood, even teachable machine uses MobileNet V2, I think V2 or V3, right? So if you see here, one is using teachable machines. What did we do? We just went to teachablemachines.com. Okay. So I think again, all of you might have done this, right? You might have seen this on my screen. This is what you have done, right? So you went to teachablemachine.com, you uploaded some images, 47 images for mango, 10 for non-mango. Again, if you look at it, it's skewed, right? I mean, the number of images are not the same, but even then it does a good job, right? So I uploaded papaya and it's saying that it is non-mango, correct? So we did all this, and then we clicked on export model, and then we uploaded it to the cloud. We got a shareable link. We took this link and we put it in our React, and we said, hey, use this model every time the user uploads an image, and then determine if the image is a mango or non-mango. Okay, so this is what we did yesterday. All is working fantastic. Okay, now the point is, what happens under the hood, right? What does teachable machine do? How does that work? Okay. So basically, if you see teachable machine, what it does is it uses a headless mobile net v1. Okay. So it use again. So MobileNet, is a model which is already trained on the ImageNet dataset. Okay. So they're all a bit confusing words. So MobileNet, ImageNet, EfficientNet, right? All these are, they get, a bit confusing after a point, but you'll have to figure it out, right? So for some days, I used to think ImageNet was a model. So then I realized ImageNet is not a model. So if you see what ImageNet exactly is, so ImageNet is 1.4 million images, okay, across 1,000 categories, okay? So you have animals, vehicles, food, household, objects, plants, blah, blah, blah. A lot of this stuff, industry standard for training vision models. Okay, so basically it's the industry standard used for training vision models, and it has weights. The weights in that the ImageNet represent again various layers, and you will find that you will have edge detectors, shape detectors, texture detectors, and all these. So what happens is when a MobileNet is trained on ImageNet, it will have since it's trained on so many kind of images, 1.4 million images across 1,000 categories, it's trained on that, right? Again, if we want to do it, it'll take a lot of computing resources, it'll take a lot of time, and I don't think we can even be able to do it properly. So these guys have already built MobileNet trained on that and has various layers. And what happens basically is ImageNet is helping MobileNet to come up with understanding the characteristics. So for example, edge detectors. If I give an object, it will be able to determine the edge. Okay, if you give a plant, it will know what are the edges of the plant. If you give let's say a car, it will be able to determine the edge of that, right? What are the shapes? How do you identify the rectangles, curves, and all this textures, object parts, complex patterns, high level comp. So the entire, the MobileNet is ready. It's already pre-trained on ImageNet. Okay, that's what it's about. Now, what we are kind of trying to do is we don't see, since we have Mango now, if we want to sit and do it, see, we just uploaded 47 images of mango, 10 of non-mango, and we said, go ahead and just do it. And it's able to do it. How is it able to do it? Because it is using the pre-trained information that it got by training on ImageNet. It knows the basic characteristics. Now we are saying, hey, this is a little bit of more mango. I'm doing fine-tuning you on top of what you already have trained. Okay, so it just takes out the existing classification layer and then trains the new classification layer, and then fine tunes that, to get the job done. So that's what we are doing today in custom approach. Okay, approach 2. So we just want to see, okay, let's try it on our own, right? Again, the teachable machine gave it's all fine, but if it looks like, it's giving us a too easy path to get stuff done. Okay, so that while it's great, but we want more control, correct? We want to be able to do more, right? If we want to do, again, end of the day, it's not you don't have to do exactly what we're doing, but I thought it's good to understand at least what's going on. Okay, so I would like you to try it again. You will face issues, but it's important to understand this. So don't worry too much if you're not understanding everything of everything, right? Some of this stuff will go right over the head. Don't worry, right? So it's more like some of the English movies, right? You don't understand what's going on first time, but maybe you watch 2 or 3 times and you'll figure it out, right? So yeah. Yeah, so here it is. So what are we trying to do? That's why for your, so try to get the gist of the idea, guys. Okay, what I want you to do is you will not become an expert in this, in this fine tuning and all that in just one session. Okay, I don't want you to become an expert also. I want you to get a understanding of what is the high level process that we are doing, right? We are taking an existing model which is already pre-trained on another a data set. And what we are saying is we replace one final classification layer with one custom class, okay? And then we are training that classification layer and fine tuning it. So that's what we are trying to do. Understand the terms, understand the high level feel for what it is. Take the code, we'll give the code also, and then you run it on your local and try it out, okay? So gradually you'll understand, then you give it, then you start, playing around a little bit. You tried more classes, and then, that's how you kind of evolve, okay? I'm not saying this is the right way to learn, but this is how I learn pretty much, right? Just get in, start figuring out what this stuff is, and of course you ask ChatGPT and Claude, and it will help you get to the details of what each one is. Okay, so of course you should always read basics, guys. Okay, no compromise on that. Read the basics and also read the code. Okay, so yeah, because see, if you just focus on theory, you'll get bored after a point, because especially deep learning gets very boring after a certain point because there's too much of mathematics and too much of theory. Okay, so you keep trying out, then you keep connecting the dots. Okay, so for a mango plant classification, what we are doing is we are taking an ImageNet pre-trained MobileNet for strong general visual features. Okay, so we are saying, hey, let me take something which is already pretty much working and has a working knowledge, replace the final classification layer. Now whatever classification layer it has, replace that and use one of our custom classes, mango plant versus non-mango plant. So we are keeping it very simple. I'm saying I don't care about mango versus guava versus where is papaya. I'm saying this binary classification, mango or non-mango. Okay. Then I'm saying stage 1, stage 2, 2 stages. I'm saying train only the classification layer, whatever classification layer we removed. I want it to train, using mango plants, and then fine tune the top layers again in the few layers at the top, along with the classification layer to boost the accuracy, right? So we are saying don't change all the layers. Now we saw there were multiple layers which I showed above, right? Like 154 layers or something. I'm saying don't touch all the layers. Okay, if you're touching all the layers, you better focus on training it on all the layers. When you don't want to do it, what we are saying is let's just pick up a classification layer and help it to identify for mango plants. Just fine tune a few top layers along with the classification layer to boost the accuracy so that it can do a better job at it. Okay, that's what we're doing. Stage 1, stage 2. So when we run the code, you'll actually see the 2 stages, and you'll see how the loss function is kind of is reducing, and then we'll see how we'll run the final. Okay, so again, just to repeat what we are trying to do here, we are trying to just do an alternative hands-on brute force approach for running the same model which teachable machine is doing, but more hands-on. We are actually importing from TensorFlow or Keras the image, the MobileNet model. We are importing it, and we will do it. Okay, more hands-on, more to get our hands dirty. Okay, don't worry, and it's not end of the world if your accuracy is low. It's okay. Okay, so transfer learning. Okay, so transfer learning is something that you'll see more like coming up as you're seeing this. So transfer learning is, again, think of a model like MobileNet as a student, right, who has already studied millions of pictures. Okay, so millions of pictures are coming from ImageNet. Okay, so a student has already studied millions of pictures. Now, instead of teaching it from scratch, okay, instead of teaching from, we transfer the knowledge to a new task. Okay, what is a new task? Finding mango plants. Okay, so we're saying, hey, you already learned so much. Let me just, instead of again doing from scratch, let me give you some additional knowledge, right? And we keep most of what it already knows about shapes, colors, and patterns. So it's already been trained on shapes, colors, and patterns. It knows how to detect and all, but it doesn't know about mango, right? So that's what we are kind of trying to train it on. So we only retrain the last parts and sometimes the top layers. So you know that it's a model which has multiple layers. So you train the top layers so that it learns the specifics of mango versus non-mango, right? So this saves time, needs less data, and still gives high accuracy. Okay. Still, it's not right to say that just 47 images will do. It's not the case, but just to understand, get things going, because we don't have enormous amount of data from our farm. We have around 200, but again, for the sake of simplicity, we're just keeping 47 for now. Okay, so benefits of transfer learning over fine tuning. Okay, so again, what we are saying is we don't want to train an entire model from scratch up or update all the layers. I'm saying just transfer what you already learned, and just make sure that it gets the job done. Okay, so works fast with small data sets. That's what we are doing. Faster training. It takes less time to train it. Less computing power. It just gets done on my system itself. Better accuracy. Okay. So what we actually did, I just talk about the steps that we actually did, and I'll show you the code. Okay. So any questions still here? Anyone?
So now we are using just we are training the model from the start. Like we are not using any pre-trained model such as teachable machine, right?
No, we are using a pre-trained model only. We are using MobileNet. Even teachable machine uses MobileNet, but it hides everything for you, right? It does everything under the hood for you.
Okay, right. Got
so we are also taking MobileNet only. They are using V1, V2. I think we are using V3, something like that.
Okay, right.
Yeah, we are using V2. I think they are using V1, MobileNet V1.
V1
is what they're using, right?
Yeah.
See, again, the point is, it's more like, if you got a car and you're able to drive around it, right? That's great, right? But we are saying, that's fine, but I want to understand what's happening under the hood in the engine, what's really there, right? Maybe if I want to tweak it to get more sound, people like this more sound cars, right? So if I want to do that, what do I do? Then I need to open it up, correct? So that's pretty much what we're doing. It's not necessary to do, but it's important to just understand what's going on, right? How does it work? It's a concept. Understand the concept around it, then dive deep into it and try to play around with it and see if you can get something better out of it, right? So because again, end of the day, if you're just going with a standard car which you get, right, there's no guarantee that it's going to there's no guarantee that you can customize it the way you want unless you understand what's happening under the hood, correct? So it's more about that, right? Yeah. So again, if you see, when you have MobileNet which is trained on ImageNet, right? It also depends on the kind of images there. So some of the things that we landed into when we were running it is the accuracy was pretty low, and even non-mango trees, it was showing as mango trees and vice versa. And what the reasons were coming out was, when the images are trained in ImageNet, they are like, sideways images. So what we have is aerial, right, through drones. So, that's why they don't support, right? So there are a number of things, right? So when you use a standard out of the box, there'll always be constraints, correct? And you'll have to work with the constraints, right? But if you don't want to work with the constraints and you have a specific use case like we do, we cannot, can we go ahead with sideways images? We can, but there are some challenges on the field, right? Because the drone, when it moves on the field, it cannot move on from the side, because if it moves on the side, it can hit one plant or other plant's branches. Okay, so it actually happened when we were actually doing the drone shooting. It went and actually hit one tree, and it actually dust went into it, and the drone got damaged. So we couldn't further do it. So the first iteration we went 2 times. The first iteration we actually had to stop it because it hit a tree, correct? And it's pretty sensitive, so a little bit of dust fell in that rotor blade, right? And it's pretty much done, right? So that's the risk involved. So you cannot do from side, because you never know what's on the side of that side. So doing aerial is always works, because what your crop's maximum height is, right? If it is, let's say, Mosambik farm, it cannot be more than maybe 15 to 20 feet, correct? So you keep your altitudes constant and just keep moving it, correct? So the eventual plan is to make it autonomous, right? So if that is the case, then you should have a robust way of how you capture the images. And of course, the way you build your model has to be consistent or adapted to how you are capturing your images, right? It cannot be the other way around, right? You cannot say, because my model is trained on sideways, I'll capture images from the side and do it, right? And that will lead to risk, right? And the last thing you want is, again, if you want to build some solution on the farm, on the field, you don't want to add more costs in terms of maintenance, right? Something got damaged and who pays for it, correct? So you want to make it robust. There will be challenges. I don't know. There will be challenges, definitely. We'll have to look at them, work them out, and make it happen. That's where you need smart engineers like you guys. Okay, cool. Okay. Now coming back, what we are saying is what we are actually doing here. Okay. So I'll walk through again. I'm making a caveat. Some of this stuff might be too much for you. Don't worry. Okay. Some of you might be hearing for the first time. Don't worry about stuff you don't understand. Try to get a general gist of what's going on. Okay. So that you can dive deep into it. You can run on your own, ask Claude for what's happening, change a little bit there. Still start reading the theory also, guys. Okay. So don't assume that what I'm saying is directly going to get into. You have to read the theory. What are layers? What are weights? What are parameters? How do you train a model? Right? All that. Okay. So so what we actually did is starting with the pre-trained brain. So we took a mobile net V2. Okay. So we are giving the weights as ImageNet, and MobileNet is V2 is the computer brain that already is trained on millions of images. ImageNet weights, if already learned to recognize, it's already the weights which are already there, which help to detect all this. So, so basically, it's like having a friend who already knows, like this is the leaf, this is bark, this is green, this is round. So it knows all those stuff. Okay. So why start here instead of from scratch? So training from zero would need millions of images and months of time. Okay. So this brain already understands basic visual concepts. Okay. So we just need to teach it to our specific task, which is mango versus non-mango. Okay. So that's what is step one. We are taking MobileNet V2, a pre-trained brain, and taking going forward. Next step, what we are doing is we are adding our decision maker. Okay. So basically we are saying, okay, look at the whole image and summarize what you see. Think about 128 different aspects of what makes a mango tree. Don't rely too heavily on any one feature, right? And make one final decision, which is mango or non-mango. Okay. So these are all the stuff which we are passing in terms of how we define the inputs. And it's like, teaching someone to identify mangoes and saying, look at the leaf shape, the fruit clusters, bark texture, then decide. Okay. So we are telling it, what do we need for you to make a decision? Okay. Then we are doing some augmentation too. Okay. So data augmentation is basically, again, real drones take photos from different angles, right? So we are trying to kind of simulate this by saying, how about I generate some images of my own, because we just have 47, right? So it's saying, if I have different conditions. So what it does is, typically, again, when the images which I show you guys is all very nice and glossy and green images, correct? So I'll just show you some images, okay, which have been taken from the real drone. Okay. So drone images, this is drone images. These are actually images which came from the field. So if you see some images, right, at the bottom, right, so they will be very blurry, right? This is a very nice and bright image, correct? So certain images, if you see, 1 second, let me not mango. So you'll see that, yeah, if you look at this, right, can you see this image? It's not clear, right? It's very blurry. I mean, you can't figure out what it is also, correct? So there will be images like this which will come, right? So it's important that you need to have images in different conditions. Okay. So why is it important to have different? See, again, this one is also a different plant, correct? If you see, it's really not clear what is this plant exactly. I mean, it's definitely not mango, but it could be lemon, whatever it is, right? So what this augmentation is basically saying is, hey, you know what? We need to simulate different conditions. So what if the same image is in a rainy condition, right? What if it is in a cloudy condition? What if it is in a, in the evening the image is taken? So it kind of simulates that. Okay. Then what we are doing is we do a two-stage learning, like I said, right? So we saying we freeze all the pre-trained layers, okay, and then just give it 10 epochs or 10 iterations and ask it to train. Okay, so don't change. So basically, frozen layers are basically saying don't change what you already know about images. Only train our new decision maker. Okay, just learn to use existing knowledge for our task, and just try to learn the mango features. Okay, so that's what this is. This is all from the code we have. Okay, so we'll look at the code also. And the second stage we are saying is fine tune the details. Okay, so unfreeze the top 10 layers for fine tuning it. Okay. Now we added the classification layer for only mango versus non-mango, and then we are fine tuning the top 10 layers to say, hey, you know what? Let me just fine tune only the top 10 layers and not everything else, and see how we can improve the accuracy of what we predict. Okay. Now you're saying unfreeze the top 10 layers means we are saying now you can slightly adjust how you see advanced features. Okay. much lower and make small adjustments. And it's like telling your friend, now that you know the basics, fine tune your eye for subtle mango characteristics. Okay, so basically two stage, and you'll see how our accuracy loss function actually decreases to increase the as we do these two stages. So so what we actually did here, and why this two-stage approach works. So first stage is fast learning, only training the decision part. Okay, can't mess up with the pre-trained knowledge, gets basics right, learns mango versus non-mango patterns. Stage 2 benefits refinement. Okay, adjust to your specific drone images. Careful learning, low learning rate prevents damage, better accuracy. Okay, so we are using the two-stage approach. So basically, again, if you look at a real world analogy, it's more like learning to drive in a parking lot. Basically, you learn in a parking lot, and then you kind of practice on real roads, so that you're still doing practicing, right? On both of these, you're still doing practicing, but learning in a parking lot is much safer, so that you can mess up if required. Practicing on real roads is you fine tuning it, you're improving it, correct? So we'll come to this. So what we're doing is basically again transfer learning to stage learning, data augmentation, overfitting prevention, validation. This way, anyhow, talked about it. So what I'll do is I'll show the code, okay? And this code, I think. So Vamsi, can you also share the GitHub repo in the chat, please? So that again I'll add it to the PPT as well, so that people can kind of pull this code and try it out on their own. Okay. So I would like all of you to also try it out. So the images you can take same images of what we did yesterday. Okay. So I think I added some more, or maybe let's see. I'll probably add these images also, whatever we are using here, so that you get the same results. Okay. So what we have here is, if you look at the code, this thing. So let me just remove some of the old and deprecated model files. Okay, so let me just remove them. It's too many files, unnecessary confusion. So mango underscore model 1, model 2. Just remove this. Yeah. So we are going to get teachable machine style 1. Okay, teachable machine style 1 is also not required. Okay, so ultimately we are going to get teachable machine style. I'll just rename this to 1. So this is the model which is stored inside this. Okay, this is a model file which comes, and what we're doing is, so we are going for a fixed text script which will go ahead and run it on that. Okay, so yeah. So first what we'll do is, okay, so I don't know if it's big. I'll make it big. Okay, I hope it's visible now. Okay, so let me close this. Yeah. So let me just explain the directory structure. Okay, what we have done here. So we are doing, we have a dataset folder. Okay. So I hope I'm audible, right? Can you give a thumbs up, please? I hope I'm audible. Yeah. Okay. Good. Screen is also visible, right? Yeah. Okay. Cool. So here, if you look at it, basically we have a dataset folder in which we have two folders. One is mango trees, mango underscore trees, and not underscore mango underscore trees. Okay. So these two folders are what determine the classes. So it directly picks the classes based on the names inside this dataset folder. Okay. So if you put another folder here, it will assume that as another class. So you have to be careful about what you name here. Okay. So once you do this, then you have a test folder where we are keeping the test images that we want the model to predict. Okay. So you can put whatever you want. I put 3 mangoes and 2 non-mangoes. Okay. So one is sitafal and another one is papaya. Okay. So this is test where we wanted to eventually test, is it working fine? Okay. So then we are looking at one main.py. Of course, you can ignore the other files. They're all test files. 2 files that are important are main.py and fixed underscore test underscore script.py. Okay. These 2 files are what are important. So main.py is the main file where we are actually doing that, training the final headless, training the final, layer, classification layer, and then fine tuning the top 10 layers, right? That is main.py. Fixed underscore test underscore script.py is what will consume the model. So once main.py runs, it will create the model as teachable underscore machine underscore style.h5. Okay, that's where the model is stored in. Okay, and once it is stored in that model, that's a trained model, you can use it whenever you want. So fixed underscore test underscore script.py is the file which will actually load that. So you can actually see in this here. So teachable underscore machine, you can see it here, right? Teachable underscore machine underscore style.h5. This is the name of the model which is being consumed. So again, whatever you name it here, that's what you have to put in your evaluation file. So it will prompt you multiple prompts. I'll show you that. Okay. So first what we'll do is we'll just go to main and try to train the model. So I'll just say, again, You will have to do the regular stuff like creating virtual environment, running the requirements or txt dependencies and all that stuff that you'll have to do anyways, guys. Okay, so that's part and parcel of standard procedure, right? You guys know it. So python main.py. So what it's going to do is it's going to, yeah, so it's running stage 1 training classification head only. Okay, so you can see that it's running the multiple epochs now. Okay, so there are 10 epochs which is running. So first epoch run, second, third. So you can see that the loss function is continuously reducing, correct? 0.7113, it's coming down to 0.27, 0.12, 0.23, and we're still in stage 1. Okay, so your loss function should be less than, ideally less than 0.3 is awesome. So stage 1 is done. Now it's doing stage 2. So it's saying fine tuning top layers. Okay, so epoch 1 or 10, again 10 epochs here. So if you're seeing the loss function is again 0.255, it will keep coming down. Okay, I think it's pretty high there, 0.47. Yeah. Okay, it's come to around 0.14, 0.196, 197, less than 0.2. Okay, so now it's saying that teachable machine style model saved. Okay, so 2-stage training completed. Head training with the frozen base. Okay, you just froze the base layers and just train the head layer, and then you did fine tuning with top 10 layers unfrozen. Okay, so now distinguish between mango versus non-mango properly. Okay, cool. Now we see that the model has been created. Yes, over here, correct. So teachable underscore machine underscore style.h5 has been created. Now that the model is created, what we need to do is, let's see if it is working fine or not. Okay, so I will do Python and then fixed test script. Okay, so fixed test script.py. So it will pull that model up and it will take the images from the test folder. But what we built is, we said, okay, let's do one thing. Let's not directly just run it from the test. I'll give an option to the user. Okay, so we have given 3 options. Option 1 is saying test on data set samples. So what it'll do is it'll take the data set samples, which is over here, mango versus non-mango, and it will randomly pick some samples and it will tell you what your prediction is. Okay, that's one. Second thing is test on dedicated test folder. So there is a dedicated test folder which we have already told it that this is test, and the test will have the test data. You can put more images of your choice. Whatever you put there, it will run on all of them and it'll tell you what the output is. Okay, so there is no UI here per se, but it will help you kind of print. It will print an image with the data on it. So we will run this option. So we can say both also. Okay, so but it's okay. We'll go with 2 because I don't see any point in running on dataset samples again, because we've actually trained and did everything on that. So we needed to run on test on something new that it is not seen, right? Something that is new for it. So I'll select option 2 and click on enter. So it's actually test on the test folder image and it's actually ran it. So if you can see it, it's saying 197 is not mango, correct? So I'll just open 197 over here. So this is basically Sithophel, right? So it says not mango class, correct, with 78% accuracy. So it looks somewhat similar to mango, but still it detected as non-mango. And papaya plant, it said mango tree. Again, it's thinking it's 64%, right? It's not very great. So again, end of the day, this is not like a perfectly trained model, right? It's not that it's perfectly, because the number of images we've given is less, and it should balance the classes, and you need to provide more data sets, correct? That's when it's more accurate. And the other thing, if you look at it, this is a sideways image.